Hello guys, in this second video I will make a small introduction to HECRAS, but before starting I would like to explain a small tool that is offered by ArcGIS software, which as I showed you in the first blog, this software you can download it for free in this time, I think until June. So you can take advantage of this, and I will explain a tool that is pretty useful for certain iterative processes that requires a lot of time to do, and well, this tool makes those kind of processes easier and faster. So let's open ArcGIS. This is the general environment, and before starting you have to insert a map in here, new map, and you can turn off this part, and you have to add the connection, the folder connection where you have all your data. In this case, the data that I will use is the same as Castellarini. Okay, and you will see all your data that we will use in this tutorial. For using any layer in this software, you only have to drag them to the main environment. And let's check if this is already projected. Reference. Yeah, so we have to turn off this. And the tool's name that we will use is called Model Builder, which is in the Analysis tab here. And what is this tool related about? This tool makes kind of an interactive process where you can program more or less in certain way the steps that you require for determining processes, in this case the watershed delineation. So we will see in the video how does it works. So we click in here, it opens a new environment, and we will see that the programming is made as a diagram which uses certain shapes for represent the different processes that we are making. So we have in here variables, iterators, logical functions. So in this part we will see only three shapes. The variables, which are represented by a blue circle, the geo processes, which are represented by a yellow square, and its output or result, which is a green circle. So first we're going to start with the raster layer, which is a variable, you can see here. And the first process that as you remember in the first video, is the fill tool. I already have it in here. Again, you can write it down, fill. This one, you drag it to the main window, and you can see that is represented in a gray color. This turns color when they have the variable that requires for the processes. So for doing this, we only have to click in here and drag. There's a small arrow that appears, so you just have to drag it to the top, to the tool, never to the result, just to the tool, and say which kind of variable is gonna be the input. It's gonna be the input surface. You organize in here, and if we opened the field geoprocess, it's gonna show the parameters that requires this tool. In some other parts require more inputs or certain numeric parameters that I will show you later. So we only also you can change in here the name of the file or the output that you want. In this case, fill raster. Okay, and it will change the name of the output in here right now. So I will place the next steps that are required for the watershed delineation. The final output of, well, no, only the process that is going to be done by the software. And for doing the system, you just have to click in here and run, but before you have to validate if everything it's okay. Okay, didn't give a problem. We run the system. It will only make until the stream features that we require, but for making the watershed delineation, we will need another step. So first, we're going to run the system, and we'll check how what does it what happens. So finally, the process is done. We can close in here. And for checking our outputs, we can, well, we will use the flow accumulation as an example. So you have to click in Add to Display, and okay, let's turn off this one. You will see here the result of the flow accumulation process. So next step is to make the string gauges location. So for this, we need to create a new shapefile. So we come here to Catalog and right click, New Shapefile. And we will need the same one, the same geometry type as the one of string gauges, which is point data. And we will call it, let's say, subcatchments. And the coordinate system. Okay. This, okay, okay. Run. And also we are going to need the position of these ones. Zoom to layer. So for creating the shape layer, we only have to go here, edit, and modify. Sorry, create. And choosing here in the right part the subcatchments layer that we just create. And as we have 8 string gauges in total, we are going to add that amount of points. And the next step is going to open the attribute table, and here we can see all the points that we are created. We are going to create a new column that will be the reference for our model builder to create the new watersheds for each string gauge. So we finish in here. Okay, and now we're the new label. We will use this ID as a reference attribute. Modify it 7 8. Okay, that's it. Let's check again if it was safe. Okay, perfect. Now we can go again to the model, and we're going to add the next tool, which is the watershed spatial analysis tool. And the variable we will use is the flow direction, and it needs another value, the variable, which is the pour point data that we just did. So we are going to look for it in here. Subcatchments. It's another variable. We drag the arrow, and again we're going to open this one and change certain parameters. Pour point field will be the ID as a reference value. The environments, we need to project our output, and the extent will be the same as the tutorial them. Okay. As we did already all the process, we only need to run this this watershed process. So run. Okay, we close in here and add to display. And you can see already all the watersheds for each string gauge. And okay, I forgot to the following step that was raster to polygon. Okay, I drag in here the raster. We opened, and okay, Again, run, close, display, and we will see every shape, every watershed delineated with the respective values of each one. Well, this is the tool of Model Builder. I hope you like it. Now we are going to focus on HEC-RAS. So I will close in here. Now with HEC-RAS, we have a pretty useful software that makes us possible to model in one or two dimensional flows and makes a lot of other stuff like temperature modeling, sediment transport modeling, etc. So in this video, I will explain you a little bit about the software environment, and we are going to make a small simulation of it. So first, we open in here. This is the environment of the software. You can download it in here in the U.S. Army Corps of Engineers. Now, before starting, the first thing that I suggest you is to change the system units in here for metric system. I have already changed it and just set as default for the new projects. And make a new project file. Search the folder where you want to save the respective project. Here, so new modeling. Okay. And I will use the same shapes as Castellarini. So in here we need the raster file of tutorial dem, but in HEC-RAS you have to use raster as a TIFF file. So for that we are going to use QGIS again. I hope from the previous video here my raster. Come here, raster conversion, and translate. Search for the raster file, and it will automatically change the raster into a TIFF file. So I have it already. So I will come here, and the next step into these tools, RAS Mapper, and in this part you will check for. You have to change the projection of your file, the project of coordinates. So we can choose a shape that we previously used in the first video. I will use the one of string gauges of Castellarini again. Open, and it will recognize the coordinates or are the projection of this file. We say apply, okay, and we can close in here. And I forgot to tell you, open in here this icon, geometric data, and just have to do save geometry data as I don't know, geo data name, okay, and close it again, and again this icon in tools, new terrain. You will add the raster of Castellarini. I have it in here. Already converted into a TIFF layer. and create. Okay, we close in here, and now we can edit the respective um, um, let's say tools that we need in order to model our river. The river that I will try to model is this one here. So for that, we will need to expand in here in the plus sign. And the first step is to edit the center line of the river. So for that, we will right click in here, edit geometry, and we will start to make to draw the line that goes into the center of the river, the most accurate possible. I will not do it all the river because I already did the modeling, but I will make only the like the main steps to show you how to do it, and then I will show you the final result. So I will just finish in here. Okay, that's approximated in here. That's okay. Escape, and you can apply a river name. I will leave the default name. Okay. Now the following step is to draw the bank lines of our river. So we will click in here. Sorry. First you have to stop the editing mode. Save it. For precaution, you can save always your job. So the bank lines, now you have to draw them. And well, it's not mandatory, but it's a good practice to draw them looking from the upstream, to draw first the left part of the river, and then the right one. So escape. Again, right click, stop editing, save. And here we have the river drawing, more or less. And if you want to see the properties of the drawings that we just made, we can go here. For example, the one of the center line. Right click, open attribute table, and it will show the feature, which is a polyline. The count is the number of points that I use. Yeah, the length of the river, the name that you gave to the river, and then nothing else. In case that you have junctions, you can also add them. I will not. I don't see any valuable junction in here except for this one, but well, I will assume that there's nothing in here. And now the next step is to make the flow paths. What is the flow paths? The flow paths is the part of the surroundings of the river that you will consider, or that you consider that they will get affected by the flood. In those cases, you can draw a larger or a smaller area, that's more or less kind of up to you. It's up to you which areas you choose or you are interested in. Maybe you have a vulnerable area in there. There are many, I don't know, there is population or there are maybe affected areas that, for example, for buildings which are quite require more attention. So you can choose them in order to see if it's gonna see if there's gonna be any damage in there. So you can have those, let's say, parameters to draw your flow paths. So again, uh, to start from the left part, let me see one thing in here. Okay, edit geometry from the flow paths, again from the left one. So in this case I will ignore, or I will make really small this part in the upstream of the river, and in here more or less increase it a little bit because, well, this area has a small elevation. That's okay. Let's make this bar a little bit wide, and that's okay. We stop the editing. Yes. And now the final step to create is the cross sections. That the info that will give the cross section is the elevation, or the, yeah, it's the section of the river that in each part, more or less, kind of in each part of the river we're going to see the elevation of our river. I will show you how after this how does it looks like. So again, edit geometry data, and for this you must consider four parameters, or must do. The first one is that those cross sections must be perpendicular to the flow direction. The second one is that there should be a span over the entire float extent. And the cross sections, as I have been doing the other drawings, must be in direction of the flow. Yeah. And the last one is that they should not intersect with another line or another cross section. So, for example, I will make this one here. So you can see it crosses all the drawings that I made at the beginning, and you must try to avoid these kind of drawings. For example, this will make an error already. So right click, delete. Also, for example, sometimes happens that this thing, so the cross section crosses into two parts of the flow path, so it will make another error. And the span that should it's just a recommendation that the span between the cross sections can be like 300 meters. I will not measure it, just try to do it as good as possible. So we have here our drawing of each part of the rear modeling. We come here and save the process, and we can close it. Now, to see what we just did, we can click in here in the 3D view. It's really not too helpful. You can rotate the view, but it doesn't say too much about what we just did. But well, after running the system, you can have a better idea of what we just did. But if you want to see each cross section, we can click in here, view cross section, and you will see each part of each cross section that we just did that is changing respect with the layer of the raster that we just used. And well, I have to make a break in here. The resolution that the raster is 30 meters, as you remember, and for these cases it's not really a good example data. We can use a better one like 10 meters or even less to have a better result. Still, because this is an example, we can make it. Here the red dot that you can see in each cross section represents the boundaries of the river in the right and left part. You can change it if you have, I don't know, surveys or data of your river. You can change them, and also you can add photographs of the place that you are modeling in exactly the exact part that you were making the survey. We can close in here, and the next step is to edit the flow data. So in this part, it is required to add the flow that your river has. Well, that depends on the studies that you did in your river, etc. I don't know. I will say that my river has a flow of 6,000 cubic meters per second. Apply data, and we will click in here, reach boundary conditions, and you will place in here the conditions of your river in the upstream and downstream parts. So in here, for example, I will place a slope of first you have to add here normal depth, and it will ask you for the slope. So let's say this is the final part, so the first part, so and normal depth also, let's say a little bit less. Okay, so for all the profiles that we did, rating curve, you can place here the rating curve if you did that for your river. In this case, I didn't do it, so we will leave it like this. Okay, apply data, and you will save again this part. So let's change it for data flow. Okay, I can close for, I forgot. We will click in here, geometric data, you will see the representation of the river, and it automatically detects the flow direction in here, in this, going to this part. And we open here the cross-section data. You can, in here you can change the position of the river boundaries, and also you can add certain data that you know, or erase any cross-section that maybe was with certain error or something, or that depends of, well, that's after your survey, what you just did, to change all the data. And the final next step is to give it a Manning value. We can change it for I don't know, a random value of roughness. Let's say 0.0. It's a usual value, more or less. And right in here, apply data, and it will make it for all the cross sections. Sometimes, well, the river has certain changes, stones, debris, whatever. You can, in that specific part, change the value of the Manning according to the data you have. So we close in here. Again, save geometry data, and close in here. Open again, just to check that everything was saved. Yep. So final step is to run the system. We click in here, perform a steady flow simulation. We want a mixed flow regime. It's really quick, the result. We close in here, and we can check again our 3D model and see how does it change our river section. You can have a better look of what we just did. Also in here you can check how does it change with time, because I just place a small value of flow rate. The appearance of the river is not that high. You can, that's up to you. And that's it, guys. I hope you like this video, and well, we will see the third one, the next topic.